Hello everyone. Today we will be talking about projectiles launched at a certain angle to the horizontal. Now, when we are talking about projectiles, remember the definition of a projectile is any object which is just under the influence of gravity and there is no other external force acting on it. So remember, we have to neglect air resistance or any other external force acting on the system when we are considering or when we are trying to find variables related to the projectile. All right, so when we are trying to make any calculation, we have to consider that there is just gravity acting on it and there is no other external force acting on the system. Now, projectile can be a combination of two different motions happening together on one particular object. That's the horizontal motion and a vertical motion. Now, along the horizontal direction, remember the horizontal component of the velocity that takes it towards that direction is always constant. So, horizontal motion is a constant motion demonstrated by a projectile. That means at every second, the distance traveled by the projectile in the horizontal direction remains constant. But if you are able to analyze the vertical movement of the projectile, we can see that the moment you are throwing something upward in the vertical direction, it will start accelerating because of the force of gravity. So this is what I was mentioning. So if you can see on the picture, we have a ball which is launched at a certain angle to the ground. So let's say that this angle is maybe theta. All right. Now, this velocity of the ball can be resolved into two components. One is the horizontal component of the velocity and one is the vertical component of the velocity. Now, why do we need to resolve the velocity into two components? So that we can analyze the role of each and every component of this projectile motion. All right. So the horizontal component takes it in the forward direction. The vertical component of the velocity takes it to in the upward direction to cover the height of it, and that's how we can analyze the overall motion of a projectile. So as we were talking about the components of the velocity, now this is what you have to keep in mind. So if there is a velocity which is at a certain angle to the ground, say for example this is the velocity, and as I mentioned, say it's making an angle theta to the horizontal. So the horizontal component of the velocity and the vertical component of the velocity can be found using the equation v cosine theta and v sine theta. Now this is basically coming from a right angle triangle. Now those who have done trigonometry, they know what it is. So if for any right angle triangle, if this is theta, this is the direction of the actual velocity. All right. So there is one velocity which is acting in the horizontal direction, which is the base of the triangle. And if you take the other velocity, which is the vertical component, and if you bring this velocity all the way towards the other side, it will form a triangle. It will form a right angle triangle, as you can see, right? So then we can say that this base of this right angle triangle would be v cosine theta, and the height of the triangle is going to be v sine theta. And that's how we are getting these two formulas, rather, that v cosine theta would help us determine the horizontal component of the velocity, v sine theta would be the vertical component of the velocity. So let's solve this problem. A baseball player leads off the game and hits a long home run. The ball leaves the bat at an angle of 30 degrees with the horizontal with a velocity of 40 meters per second. How far will it travel in the air? So let's draw the picture first. So we have 40 meters per second as the velocity of the projectile, which is launched at 30 degrees to the horizontal. So for any velocity which is making an angle with the horizontal, Remember, we can split up the velocity, or we can resolve the velocity into two components. One is the horizontal component, the other one is the vertical component of the velocity. Horizontal component is indicated by v cosine theta, vertical component is indicated by v sine theta. And why are we analyzing these two components? The reason is we are trying to determine the role of each component for the motion of the projectile. So if we follow the same scenario, we can see that our v in this case is 40 meters per second. So we can write the velocity along the horizontal Vx is 40 cosine of 30 degrees. And if you are able to find out the value of it, it's going to be 40 cosine of 30 degree, and that's going to be 34.64. Okay, now this is the projectile's velocity, which is taking it in the forward direction and helping it to cover the range. So if we draw the picture, this is how the picture is going to look like. It's going to go all the way up and then it's going to come down. So this will be the actual path with the projectile. This is the height of the projectile. And this horizontal displacement is the range of the projectile, right? From the starting point to the end point. Now let me erase this picture that we have done, that we have actually drawn over here. So remember, the vertical component has to be v sine theta, and this is what we are going to derive right now. So if we find out the value for the v sine theta, so that's going to be 40 sine 30, and that's 20 meters per second. So 20 meters per second is acting upward. That will help the projectile to cover the height of it. So it will take it through this height. This is the height that it attains, all right? And the horizontal component of the velocity, which is Vx, will help it to attain the range. So we can say that Vy, which is the vertical component, that's the initial vertical component of the velocity, is 20 meters per second. And Vx, the horizontal component, is 34.64 meters per second. Now, if you look at this table on the right-hand side, delta x indicates the displacement. So displacement for the horizontal direction is called the range. Displacement for the vertical direction is called the height. Vi is the initial velocity, Vf is the final velocity, A is the acceleration, T is the time. So let's write down what we know. So since the horizontal velocity of a projectile always remains constant, so we are going to write for Vi and Vf in the horizontal section 34.64 for both of them, because this is remaining constant and this is taking it through the range. Now remember, along the horizontal direction the acceleration is 0. There is no force acting along that direction. But now if you consider the vertical direction, it's always the force of gravity. The moment something is launched vertically upward, gravitational pull is always acting on it and it's trying to pull it down. So we have the gravitational force acting on it. So the acceleration will be, say it's 9.8, but let's take, for the sake of calculation, as 10 meters per second square. That's the acceleration, which is negative, of course. Negative 10 meters per second square, which is always acting downward. Now for the vertical direction, the initial velocity is 20 meters per second, as you can see in the picture. So we are going to write 20 meters per second for the initial vertical velocity. But when it reaches this height, the maximum height, what happens? So when you are launching something, when it reaches the maximum height, what happens to the object? You may have noticed that the velocity becomes zero momentarily. And why is it so? Because as it is going up, it's slowing down. So the direction of the velocity, the direction of the initial vertical velocity is upward. But the force of gravity is always pulling it downward. So just because there is a force which is always trying to act in the opposite direction, the overall velocity of the object will slow down. And finally, when it reaches the maximum height, it will stop momentarily, and then it will change direction and it will start coming downward, right? So therefore, the final velocity, now this is what we are talking about, the final velocity. So this is where the final velocity is, the maximum height. So the final velocity for the projectile at the maximum height is going to be 0 for the vertical direction. All right. So we know all of these things. Now we don't know the time. Now time taken for the horizontal. Now remember that these two times are different. And why is it different? The reason is the projectile basically is going up from this point all the way up. So this is the time it takes to cover just the height. Now it's taking the same time to come down. So if you are talking about the total time that it takes to cover the range, that will be double the time that it takes just to go up. All right. Now let's use the equations that we know for solving these problems. So the first equation is to calculate the time. So we know as the projectile is going upward, it's slowing down. So the final velocity from the kinematics equation comes out as Vf equals Vi minus Gt. These are the free fall equations. So as we know, the final velocity is 0 in the vertical direction. Initial vertical velocity is 20 meters per second, as we know. This is the velocity with which it is going up. It's 20 meters per second, so we can say 20 minus 10 times t. Gravity, this is acceleration due to gravity, which is g, and g is 10, so 10 times t. Now bring 10t on this side, you are just solving an equation, and this is 20. So t will be 20 over 10, and that's going to be 2 seconds. Now this 2 seconds is the time during which the projectile is going up from this point all the way up to this point, to the maximum height. So naturally, as you know, that there is just the force of gravity which is acting on it, and we are kind of considering that there is no other external force acting on the system. So therefore, it will require the same amount of time to come down. So it's going to be another 2 seconds to come down. So now if you are writing the time for the vertical direction movement, so when we are talking about the vertical direction movement, it's just the height. So we are going to write for the time just 2 seconds under the vertical direction section, under the vertical section. But when we are talking about the total time that it takes to cover the range, it's going to be 4 seconds. All right. So now we know the time that it takes to cover the range and time it takes to cover the height. So let's find out the range now. So the range is equal to horizontal component of the velocity, which is Vx, and that is 34.64, times the time taken to cover the range. And in this case, it's going to be twice t, which is 4 seconds. So we are going to write 34.64 times 4 seconds. So if we do that, that's going to be 138.56. So it's going to be 138.56 meters. All right. And now if we talk about the height attained by the projectile. Now remember the height equation for projectile is h equals 1/2 gt squared. And this is also coming from kinematics equations. So height is given by half times gravitational acceleration, which is 10, times the time it takes to cover the height. Now remember, for the height, it's just going to be 2 seconds, so 2 squared. And so if we calculate it, It's going to be 2 times 10, which is 20 meters. So 20 meters is the height. All right, so you can see our question was, how far will it travel in the air? So when we are talking about how far will it travel in the air, we are actually talking about the range. So the range basically is 138.56 meters. When we are talking about the hang time, now remember this is not mentioned in this question, but even then, if there is a question on hang time, that's the total time taken by the projectile to go up and come down. So the total time spent by the projectile in air, that's called the hang time. And in this case, the hang time is the time taken to go up and come down. That means it's going to be 4 seconds. So this is the hang time. And also you can see the height we have already calculated. And that's how you're going to solve these kind of problems on projectiles when it is launched at a certain angle. I hope this video is helpful for you. All right. All right. Take care.